Welcome, my students, again. Chapter 3, we are in Chapter 3, Lesson 3. Today, our lesson is Newton's third law of motion. What are the learning objectives of our lesson? By the end of the lesson, every student should be able to the following. You have to state Newton's third law of motion by using your own words, not by memorizing the Newton's third law only. Now, second, we have to explain the concepts of action and reaction forces by giving some real examples. The third, you have to write the third law of motion mathematically in mathematical form. At the last, there is a misconception in the Newton's third law. We have to clarify and eliminate all these misconceptions. I think it is clear. Yes, Roble, it's clear. This is the purpose and the specific objectives of our lesson today. Before we go deep to our lesson, I have a question and I have a story. Which is the first? Mr. Ahmed, which is the first? Story or a question? Story here. One day after my class, a student came to me and said, "Oh, my teacher, I have a complaint. When a student is punching me on the shoulder, he punched me on the shoulder. Still, I'm feeling pain." I called the other students to my office and asked him, "Why you punched? You punched the boy, your friend. Why you punch?" There is what was his response? Do you think that response? He said, "I was doing an experiment about your lesson yesterday, Newton's third law of motion. Since there is action and reaction, so that I punched him. This is the action, and I was expecting him to the reaction. Very strange. I think you understand. So now you are the judge. After taking this lesson, you will be the judge between these two students fairly. When you understand this lesson, you can be a judge. Today our lesson is the third law of motion. It is impacts of the life and the misconception is around that that law of motion. Before go to the lesson to the third law of motion, we already explained it. Second law and first law. Who's ready to repeat again? Yes, Mr. Ahmad. Newton's first law. Yes, it's an inertia law. That's great. And you, Mr. Hassan, Newton's second law. Mathematically, simply mathematically. F is equal to what? Equal is equal to MA. That's good. So, what's the force? The force. Yes? Halima, force is an external cause which causes a moving body to stop or to start moving or to change the direction. How many types of motions are there? Common types of motion. Common types of force are there. Yes, thank you very much. Push or pull. Push or pull. Types of motion. So Newton's law of motion, it has that represented to two pairs. In nature, it has two pairs. One pair, one force against the other, and the other force against the other. If you have two different, these two, one is bottle and another, one force accept another force. So this is A and this is the P, A exerts on P, and while the P exerts on A. I think this is clear, very clear. Then, two important features in this concept. To remove, to eliminate the concepts. This is where the misconception arises. First, the forces exerted are always equal in magnitude and equal in direction. They have to be equal in magnitude. Their number, for example, 10 Newton and 10 Newton, but opposite in direction. This is going left and this is going right. The second, the second factor is these two forces acting on the different bodies, not on the same body, different body. This is one body and this is another body. When these two are acting on each other, those forces acting on two different, so they cannot cancel. But if there is a portal, one force in here, another in on here, another is here, this is one single. This is not in the case of Newton's third law. Newton's third law is necessary to be two objects. This is the misconception where the misconception arises. I think it is clear, clear enough. Yes, it is necessary. Two objects are necessary. Two objects. For example, the wall and the person, the pole and the person. Two different objects, not in one. This is the now it's clear. No misconceptions. It says what? Whenever one object exerts a force on one another object, the second object exerts an equal and opposite direction. They are equal. If one is 10 Newton, the other is minus 10 Newton. Equal in number, but different in direction. The sign plus and the sign minus means different directions. Well, how about the real life? Can we get this in real life examples? Can we get a real example life? Real examples? Yes. Let us take some and you will get others. As the professor paces in front of the whiteboard, he exerts a force backward to the floor on the floor. One is on the floor and one is on the professor. That is making the professor paces in front of. There's two different forces with different objectives. One is the floor and the other is the person or the professor. The second one, helicopters, when they are flying helicopters, they are pushing air down. When air is pushed down, another upward reaction force. So it is flying up. This is another important concept. Then a good example, when a person pulls a vertical rope and the rope pulls up in the vertical on the person. This is an example, good example here. Here the picture is there. I think it is clear. Now, different. Do you have any extra real examples? Yes. The boat, yeah, and the gun, the fire, and the other is the back. Do you have another? Try to get some other examples out of the book. Please, please be out of the box. Think critically out of the box. What about the key points? Who one of them can summarize the main point of the lesson? We are talking about Newton's third law, about action and reaction, about two objectives. One has a force and the other has the equal force, but in different directions. In different directions. Key points. The misconceptions arise from where? From mixing two objectives or one objective. When there are two objectives, Newton's third law. When there is one objective, no, at that time is not concerning with Newton's third law of motion. Now I will check your understanding. Give me some examples in daily life. in your environment. Pick some different examples. When you understand a lesson, you have to explain your grandmother. If you explain your grandmother, means you understand that lesson. Or, as Einstein says, you have to explain a 6-year-old child. That's enough today. Thank you very much, all the students.